Below is a comprehensive English-language text about our solar system's 8 main planets, from Mercury to Neptune, plus a brief mention of Pluto, now categorized as a dwarf planet. Please feel free to copy and paste directly into your video creation software. The Sun is our solar system's central star, providing light and heat essential for life on Earth. Over 99% of the system's total mass belongs to the Sun, whose strong gravity keeps the planets in orbit. In this text, we'll explore the 8 officially recognized major planets, each with its own fascinating traits. We'll then discuss Pluto, which once counted as the 9th planet but is now reclassified as a dwarf planet. 1. The Sun. Heart of the system, though not a planet, the Sun is the bedrock of all activity here. 1. Composed mostly of hydrogen, ash 74%, and helium, 24%, plus minor heavier elements. 2. Diameter of about 1.39 million kilometers, some 109 times Earth's diameter. 3. In its core, at about 15 million degrees C, hydrogen fuses into helium, releasing huge amounts of energy. 4. It shapes the entire solar system's conditions, temperatures, radiation levels, and gravitational structure. Without the Sun, the Earth would be a frozen, lifeless world. Every planet we'll see next owes its climate, day length, and orbital properties to the Sun's presence. 2. Mercury, the smallest and nearest to the Sun. 1. Basic facts. Mercury is the innermost planet, with a diameter around 4,080 kilometers, making it the smallest of the 8. Its orbital period, a Mercurian year, is only 88 Earth days, so Mercury whips around the Sun faster than any other major planet. However, a Mercury solar day, sunrise to the next sunrise, is about 176 Earth days due to a spin-orbit resonance, 3 rotations for every 2 orbits. 2. Temperature extremes and minimal atmosphere. Mercury has almost no substantial atmosphere. The thin exosphere can't retain heat, so daytime surface temperatures can exceed +400 degrees C, while nights drop to about 170 degrees. And because there's no thick air, heat cannot distribute around the planet, resulting in enormous thermal swings. 3. Surface and exploration. Mariner 10, 1970s, and Messenger 2008-2015 revealed a cratered surface resembling our Moon. Yet Mercury also has a large iron core relative to its size, with a relatively thin rocky crust. 4. Special notes. No moons, no ring system. Viewing Mercury from Earth is difficult because it remains close to the Sun's glare. 3. Venus, extreme greenhouse and Earth's sister. 1. Overview. Second from the Sun, about 12,100 kilometers in diameter. Earth's diameter is 12,742 kilometers. One orbit, Venus year, is 225 Earth days. Yet one full rotation takes about 243 Earth days, and it rotates retrograde, backward compared to most other planets. 2. Hellish atmosphere, a thick CO2 atmosphere with clouds of sulfuric acid. Surface pressure is 990 times Earth's, and temperatures hover around 460–480 degrees C due to a runaway greenhouse effect. And this makes Venus hotter at the surface than Mercury, even though Mercury is closer to the Sun. 3. Rotation and missions. Because of its slow retrograde rotation, a Venusian day is longer than its year. Soviet Venera landers survived only minutes to a couple hours in the lethal conditions. Japanese probe Akatsuki studies cloud patterns from orbit. 4. Why sister planet to Earth? A Venus is close in size and mass to Earth, but the conditions are drastically different. No liquid water, an extremely dense and toxic atmosphere. 4. Earth, the only known world with life. 1. Key data. Third planet, 12,742 kilometers in diameter, 70% covered by oceans. One Earth year is 365 days. One day is 24 hours. 2. Atmosphere and habitability. Dominated by nitrogen, 78%, and oxygen, 21%. Liquid water, moderate greenhouse gases, and a strong magnetic field help sustain stable climates suitable for life. 3. Moon. Earth has one large satellite, the Moon, diameter 3,474 km, and it regulates ocean tides and helps stabilize Earth's axial tilt. 4. Life's uniqueness. Earth is the only planet so far confirmed to host complex life. Biodiversity ranges from tropical rainforests to polar ice caps, reflecting Earth's dynamic geology and stable temperature range. 5. Mars, the red planet. 1. Dimensions and orbit. Fourth planet, diameter. 6,192 km, about half Earth's. A Mars year lasts 687 Earth days. One Sol, Martian day, is 24.6 hours. 2. Reddish surface and thin air. Rust-colored dust, iron oxide, covers the surface. As the mostly CO2 atmosphere is only 0.6% of Earth's surface pressure, creating big temperature swings from plus or 20 degrees C at the equator by day to 140 degrees near the poles at night. 3. Remarkable features. Olympus Mons, the tallest volcano in the solar system, 25 kilometers high. Valles Marineris, a canyon system thousands of km long. Then many rovers, e.g. the Viking, Curiosity, Perseverance, search for ancient water flows or microbial life indicators. 4. Future exploration. Mars is a prime target for potential human missions in coming decades. Yet colonization faces hurdles: low atmospheric pressure, radiation, cold climate. 6. The asteroid belt, series and more. 1. Location. Between Mars and Jupiter lies a band of countless rocky or metallic objects known as the asteroid belt, and they range from boulders just a few meters across to hundreds of kilometers in diameter. 2. Ceres. At 940 kilometers in diameter, Ceres is the belt's largest body, now classified as a dwarf planet. And NASA's Dawn spacecraft studied it up close, discovering bright spots likely linked to salt deposits and possible water ice content. 3. Why no planet formed there. Jupiter's strong gravity likely prevented the material from coalescing into a single planet, so these fragments remain mostly separate. 7. Jupiter, the massive gas giant. 1. Basics, fifth planet from the Sun, diameter 139th, 820 km, 11x Earths. More massive than all other planets combined, excluding the Sun. Orbits the Sun in 1186 Earth years. 2. Atmosphere and the Great Red Spot. Mostly hydrogen and helium. Distinctive bands of clouds are visible, driven by powerful winds. And the Great Red Spot is an enormous storm, at least centuries old. 3. Rapid rotation. A Jovian day is 99 h56 minutes. The high spin rate flattens the poles. The Jupiter radiates more heat than it receives from the Sun, due to slow gravitational contraction and leftover primordial heat. 4. Moons. Jupiter hosts over 90 known moons, including the Galilean ones: Io, volcanic; Europa, subsurface ocean; Ganymede, largest moon in the solar system; Callisto. As these diverse satellites make Jupiter a mini-system in itself. 8. Saturn, the famous ringed planet. 1. Key facts: sixth planet, as a 116,460 km in diameter. Very low density, less than water. 2. Spectacular rings made up of ice and rock fragments. They appear thick, but are typically only a few tens to a few hundred meters thick, spanning hundreds of thousands of kilometers outward from Saturn's center. 3. Moon. Saturn has over 80 confirmed moons. Titan, the largest, has a dense atmosphere of nitrogen and hydrocarbon seas. Enceladus spews geysers of water vapor, suggesting an ocean beneath its icy crust. 4. Orbit and internal heat. One Saturnian year is 29.5 Earth years. And like Jupiter, Saturn emits internal heat from helium separation in its interior. 9. Uranus, the tipped-over ice giant. 1. Characteristics: seventh planet, 50,724 km in diameter, an ice giant. Year: 84 Earth years. Rotates in 17 to 18 hours. 2. Axial tilt. Uranus is tilted at about 98 degrees, so it orbits the Sun almost on its side. This leads to extreme seasonal patterns, with each pole potentially facing the Sun continuously for decades. 3. Atmosphere and color. Mostly hydrogen, helium, and methane, giving a pale blue-green color. And temperatures can drop to around 220 degrees C in the upper cloud layers, arguably the coldest environment among the main planets. 4. Rings and moons. Uranus also has thin, dark rings discovered in 1977. Over 25 known moons, including Titania, Oberon, Ariel, Umbriel, and Miranda, named after Shakespearean characters. 10. Neptune, windy outer world. 1. Overview. Eighth planet, free 4.5 billion kilometers from the Sun, depending on orbital positions. and diameter 249,244 kilometers, orbit 165 Earth years. 2 atmosphere, like Uranus, hydrogen, helium, and methane, and features extremely fast winds over 2,000 km/h and occasional giant storms such as the Great Dark Spot, which appear and vanish over time. 3. Moons. Neptune has around a dozen or more known moons. The largest is Triton, 2,700 kilometers in diameter. Triton has retrograde orbit, implying it may be a captured Kuiper Belt object. 4. Exploration. Only visited up close by Voyager 2 in 1989, future missions might reveal more about Neptunian dynamics and its unusual satellites. Pluto and the dwarf planets. 1. Pluto, discovered in 1930, classified as the 9th planet for decades. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet. Diameter 2376 km, smaller than Earth's moon. Its largest moon, Charon, has 1,200 kilometers diameter, sometimes forming a binary system with Pluto. 2. New Horizons, 2015. NASA's New Horizons spacecraft gave the first close-up images: plains of nitrogen ice, possible water ice mountains, thin nitrogen-based atmosphere, and this revealed Pluto as a surprisingly dynamic world. 3. Other objects. Past Neptune's orbit, we have the Kuiper Belt, dwarf planets like Eris, Haumea, Makemake, etc. The solar system extends beyond these edges, possibly to the hypothetical Oort cloud of comets. Why does this matter? From scorching hot Mercury to ice-cold, windy Neptune, each planet offers unique insight. 1. Mercury. Minimal atmosphere, huge temperature swings. 2. Venus. Runaway greenhouse, extremely hot. 3. Earth. Water life, stable climate. 4. Mars. Potential ancient rivers, future colonization target. 5. Jupiter. Biggest swirling storms, many fascinating moons. 6. Saturn. Mesmerizing rings, large system of satellites. 7. Uranus. Sideways rotation, cold upper atmosphere. 8. Neptune. Fierce winds far out in the solar system. 9. Pluto. Once a planet, now dwarfed by definition, yet still enthralling. Space agencies keep sending probes, like rovers on Mars, Juno at Jupiter, Cassini, until 2017, at Saturn, and prospective missions for icy moons or the outer planets. Our knowledge evolves with each discovery. Understanding these worlds tells us about the formation of planetary systems, the possibility of extraterrestrial life, and Earth's own place in the cosmic puzzle. If you enjoyed this solar system overview and want more content about astronomy, please give this video a like, drop a comment sharing which planet, or moon, fascinates you the most, and subscribe to our channel so you won't miss future space-related explorations. Your support helps us create more in-depth materials about the cosmos. Thank you for reading, and see you in the next cosmic adventure.